So let's continue for some sample problems of oxidation reduction chemical reaction. Okay, let's drink coffee. At this time, coffee with milk. Oh my gosh. Without sugar again. Okay, but this time I'm gonna eat two pieces, white bread that's too hot. I cannot hold by my hands. Still hot. So while doing that, I may start now my explanation. Right? So it's gonna be like that. So we have aluminum plus copper chloride or copper chloride. Now, what is the atomic weight of aluminum? Okay, 26.98 grams per atom. And then the atomic weight of copper is going to be 63.55 grams per atom. The atomic weight of chlorine is going to be 35.45 grams per atom. Then automatically we can now determine the molar masses or the molar mass of copper chloride. Okay, now we'll transfer that here so that we can start now our oxidation reduction. Okay, so aluminum. So again, we have now an idea. Aluminum is an electropositive, so it's gonna be a reducing agent. So it will become oxidized, right? And undergoing a process of oxidation. Okay, things like that. Sometimes we need to memorize quickly if we already understand. Okay, something like that. So aluminum plus copper chloride. So in this reactant alone, we can really predict that it's going to be following the type of chemical reaction, which is a single replacement or double replacement. If you can see one is the element and the other is a compound, automatically our judgment will lead us to the confirmation that it is going to be the single replacement or the single displacement type of chemical reaction. Okay, like that. Now, since we talk about displacement, now the copper will be displaced by the aluminum. Okay? You get the point? Because displacement or replacement. Okay? So it's gonna be copper plus aluminum chloride. But check. What is the charge of an aluminum and the copper here? When it is being chemically combined with each other, the charges will be yielding a charge, different charges. Okay, now we start with a rule. Since solo aluminum, or let's say pure substance or pure element aluminum, so we have a zero oxidation state or oxidation number or oxidation or a charge. Okay, like that. Secondly, we have the copper chloride. So this is a neutral compound. Okay, because there's no charge at the top. So meaning to say, so we have the chlorine, sure, that's gonna be a halide family with a charge of -1. So we need to say, so this neutral compound, copper chloride, is equal to 0. Okay, like that. So equal to 0. Okay, and then we have to carry the -1 charge of chlorine here. Okay, so let X as the oxidation state of copper. So X times the subscript of copper, which is 1 because nothing, okay, plus the charge of chloride, -1, plus the subscript of 2 because there's a subscript of chlorine, which is 2. Now solve for the value of X, basic math. Okay, so X times 1 is X, -1 times 2 is -2. Okay, automatically it will become -2 is equals to 0, then transposed to the right, it will become X is equals to +2. Then 2 is the oxidation state of copper, +2. Okay, like that. Okay. And then we go now to the product. So we have a cuprous plus aluminum chloride. Now, here, we judge aluminum chloride as AlCl2. So meaning to say this is using the charge of the aluminum 3, right? 3. Okay, like that. So aluminum chloride or iron or aluminum 3 chloride. Okay, aluminum 3, Roman numerals 3 chloride or aluminum chloride only. Okay, will do. Because there's no such aluminous, aluminic, there's no terms like that in the case of aluminum. Okay? You got the point? Okay, so like that. Okay, now, so we need a -1 for chlorine, right? Put -1 inside the parenthesis first. Okay, and then again, follow the rule. Since we know already that it's positive, to make sure talaga siya. Okay, so we need to have equal to positive 3 because this is a compound, metallic compound. Okay? You get the point? Now, let X as the oxidation state of aluminum. So we will say X times 1 and then go to the chlorine. So -1 times 2 times 3. Right? Because there's still 3 in the parenthesis of chlorine. Okay, but in the aluminum, it will never carry the 3 because that is not coming from the aluminum. It's not included in the parenthesis in math. In math, only the parenthesis inside will yield the multiplication process. But if it's not inside the parenthesis, you will never multiply that. Okay? That is distribution multiplication in math. Okay? Like that. Okay. 1 times S is X. Okay? -1 times 2 times 3 is going to be -6 is equals to 3. Then X is equals to -6 is equals to 3. Transpose 3. Then we're going to show chuba-chucho. Okay? Plus 6. Okay? So X is equals to 9. Okay? So our charge for aluminum is 9. Okay? Then, mga palangga, if you are confused with your charge because it's too much, review again. Okay? Okay? So that you will get the correct or precise or accurate oxidation state. Okay, mga palangga. It's gonna be like that, right? Okay. Okay. So, let's erase this first to make it to have clarity. Okay. Like that. So, aluminum chloride. Okay. Right? So, aluminum chloride. So, the start of chloride, because that is the thing when it happens. Guys, it really helps you to pass examination. Guys, if you sometimes you will see not really valid or not really valid, if you found it really suspicious in your answer, you have to repeat that once, especially if that is not too difficult, because it will waste your time stucking in one problem if you keep on repeating over and over again and there's still another questions after 10, 11, 12 like that, and your score will be deducted. For example, there will be 150 questions and then in item number 9 is very difficult and you review already twice and then you cannot still make it, proceed to another number. Things like that also, because you can suspect really by your judgment, oh, what's this too small, too big, like this, I obtain a charge which is positive, then in with a periodic table, in periodic table, it can never be happening because it's only up to group 8A. So see, your mind will work for that. The periodic table last group is only up to 8, but why you produce a charge which is more than 8? So something wrong. That's why I told you we have to repeat, right? Okay, things like that. Okay, now, so we replace that with the aluminum chloride. So chlorine is -1 and then aluminum is 3. We start for the minimum. So this is going to be aluminum chloride. Okay, it's going to be AlCl3. Okay, not AlCl2. Things like that because there are transition metals that have 2 charges. Okay, so take note also for that. Okay, AlCl3, not AlCl2, whatever. Okay, like that. Now, so again doing the same step, so equal to 0. Okay, so aluminum X, you need to determine so X times 1 plus chlorine charge of -1 times 3 because there's a subscript of 3 in chlorine. So X times 1 is X, -1 times 3 is -3 is equals to 0. X is equals to 3. So the charge or oxidation state of aluminum is 3. Positive 3. Okay. Like that. Erase. Then copper. What is the charge of oxidation state of copper? It's a solo flight element, meaning single, pure metal. So it's gonna be 0 automatically. Okay? Like that. That's the rule. Okay? Okay, now determine the oxidation process and the reduction process. So, aluminum from 0 to 3. Okay, that is increasing oxidation number. Then meaning to say loss of electrons. So, oxidation. Okay, loss of 3 electrons. Then therefore oxidize. Then I said earlier, this is reducing agent. Aluminum is a reducing agent. Okay. Okay, now, what else? Copper, chlorine, chlorine. Chlorine, okay, take note of the chlorine, -1 and -1, so there's no changes. If there's no changes in the oxidation state, do not include that in your oxidation and reduction process. Okay? Like that. So, aqueous. Chlorine is aqueous. Okay, now we go to the copper. Okay, copper is +2, then down to 0, so the decrease in oxidation number is gonna be reduction. Okay, then it's gonna be increase in oxidation state. Okay, decrease in oxidation state, sorry. So this is gain of 2 electrons. Ang makalimutan niya guys is only the reverse. The electrons is the reverse of the oxidation state and the oxidation number. It's always like that. Okay? Since it's decreased from 2 to 0, decrease in oxidation number, meaning gain of 2 electrons, right? And then it's reduced, meaning oxidizing agent. So, oxidizing agent. Okay. Now, in your oxidation process, normally, you're oxidizing, or the substance being oxidized is your aluminum chloride, not the aluminum, because compound in the rule, ha? So aluminum chloride is your reducing agent. Okay, reducing agent, or it is being oxidized. Now, in your reduction or gain of 2 electrons, reduced is your cuprous chloride. Okay, not the copper only. So, cuprous chloride. So, it's gonna be your oxidizing agent. Okay. Oxidizing agent, mga palangga. And then, substance or element reduced. Okay. Ganon. So, you can now identify. For example, wala pa nagbuhat, anaan mo ng question sa examination in the future. In the reaction of aluminum cuprous chloride, which of them is the oxidizing agent and which is the reducing agent? If you don't have an idea, then nga. So you have to do the redox equations like this so that you can answer. Or by this only, the question will say, in reaction of magnesium oxide plus water, which is substance or element being oxidized, which substance being reduced. If you don't have an idea, you cannot answer. Okay, that's why we need to do the redox process. So that's the purpose. Okay, ganon. Okay, now go to the half reaction. Okay, so for aluminum, right? Okay. Half aluminum is gonna be reducing, so oxidation ng aluminum, mga palangga. So it's gonna be like this. Okay, OHR, oxidation, half reaction. So aluminum. So, di ba na 0? When you do the half reaction, you don't have to put the oxidation state and the charge anymore. Put only aluminum like this. And then, loss of electrons gonna be, the adding of electrons will be in the right. Okay? Because there's no such negative in adding to the left for the reactant. Okay? It's gonna be like this. Okay, aluminum is equal to, and take note the aluminum in the aluminum chloride, of course. Okay, because the aluminum is there. Okay, aluminum chloride is gonna be, what's the charge? Aluminum, positive 3 plus 3 electrons. You terminate the chlorine, because the chlorine have the same charge, it will never include in the redox. No changes at all in the charge or oxidation state. Okay, now it's gonna do like that. Some books, guys, are putting aluminum as a solid precipitate. Aluminum as a solid precipitate. But you don't have to worry. If we have the aluminum, that means solid precipitate. The S is just being put there, but it's understood. Okay? Something like that. Okay, I'll just remove the S. Okay, solid. Okay, now we have the reduction, half reaction. So it's being reduced is the copper, right? And copper is here. Okay, so that is being reduced or reduction takes place. It's gonna be the adding of electrons in the left. Okay, so plus electrons in the left. How many electrons are being gained? It's gonna be 2, right? So 2 electrons. So starting from cuprous positive 2. Okay, take the copper individually. So copper positive 2 plus 2 electrons is equal to the copper here. Okay, the copper here is actually copper 0, right? And you don't have to put any more. That's copper understood because it become now as again a solid precipitate. Okay, when it become a solid precipitate, okay, when it become a solid substance in your reaction, in your redox, you don't have to put the charge anymore with the oxidation state. But in the adding of electrons chuba chucho, you have to put the charge in the oxidation state. So that these are our techniques already in how to do this. Okay, as you can notice, if I add 3 electrons, the element will have a positive charge like this, but the product is a solo flight chuba chucho. Okay? Solo flight meaning usa ra gyud siya ka element, one element, and no charge at all. Ganon. Okay? So like that. So SRP, standard reduction potential, it's in here. Okay, reducing man siya. So it's gonna be the copper. Okay? So if you go to the books, guys, you will say copper plus 2 electron is equal to copper. This is the SRP. South Reclamation Project in Cebu. SRP. No, it's not. It's, okay, standard reduction potential, okay, of copper. You get the point? Something. It's expressed in this way. Now you can reverse that one. It depends on your redox to match the other one to cancel the electrons in your final reaction. Okay? Because you want to cancel that later on. You get the point, mga palangga? Okay. So in this case, mga palangga, 3 electrons is not equal to the 2 electrons in copper. Then multiply each by 2. Okay? Start with 2, not 1, because if you multiply 3 by 1 and 2, it will not be cancelled. That's why 2 is the next to 1. So that's why 3 times 2 and 2 times 3. So 6 electrons na. After that, it will become 2 aluminum, okay, plus 2 aluminum positive 3, plus 6 electrons in the oxidation. Now here in your reduction, it will become now 3 cuprous or copper positive 2, then 3 times the 6 electrons, and then 3 copper without charge. Then add the 2, then cancels the 6 electrons somewhere along the way. Then we can have the final, okay, redox product will be 2 aluminum. Put in the same group all the reactants and the same group all the products. Okay, so 2 aluminum, okay, plus 3 copper positive 2 is equal to 2 aluminum positive 3, okay, plus, ano lang siya, dili ko to. So this is now our final redox. 2 aluminum plus 3 copper positive 2 plus 2 aluminum plus 3 copper pa siya, itago, dili sa ubos. Wow! Okay, nakakaloka, di ba? Okay, ganon. Okay, yes, gonna be like that. Okay, perfect. So, number 3 is already kalas. Okay? Get the point? So, not only limited to, 2 electrons. As usual, in electrons, sometimes you will multiply that to balance it and to be cancelled out. Okay? Not all the time 2, 3, like that. Okay? Get the point? Okay. Like that. Now, we go to the magnesium oxide plus water. Nakakaloka. Okay. Coffee for life. Mga palangga. Diba? See for a while. Napaig. In fairness. Oh, diba? Tadadan! Bread. One bread, one dinner. Diba? Ang gusto ko ani, usa ka buok. Number, solve by yourself, guys, from 4 to 9. I think the difficult one here is the dichromate. Dichromate plus hydrogen ion. I think it's difficult to produce the products, okay? Dichromate. It's not unusual. It's unusual because that's dichromate. The most popular is the chromate only, CrO4. But this one is dichromate, Cr2O7. Okay? Take note, we have the chromic acid, but we don't have chromous acid, right? Okay, because this one, di ba? Ang chromium, positive charge kay. It belongs to the, ano man siya, positive 6 valence electrons. So, positive 6 valence electrons in the outermost shell. Diba? Okay? Hello, mga palangga! Aniya sa ako. Oh. Harun iyag-yag kan yung tanan ang redox chemical reactions. Okay, number 4. Magnesium oxide plus water. Okay, water. Okay. Now, investigate the compounds. Compound plus compound. Oh, no. Okay, we have a rule that if all are compounds, it's not a redox equation. But take note, upon predicting the products, maybe the products don't have an element or don't have a compound, then judge it. Okay, here. So if you add the water, so this is hydrolysis or hydration process adding water, right? So actually, this is gonna be a weak acid and a weak base. So the base here is basically magnesium hydroxides, right? Because there's OH. So magnesium hydroxide. Okay, but take a look. You cannot pair magnesium hydroxide to other compound. Okay, because there's no other element involved, only magnesium, and the other one is water. So instead of having an acid, you could no longer have an acid. Okay, because there's no other element involved. Okay, like that, things like this. Okay, even though this is a hydrolysis, but there's no other element involved, then you can have only one base. No acid. See? Can you see? Okay. Like that. So it's going to be magnesium hydroxide. So magnesium belongs to the group 2A, the charge is positive 2. Okay. So hydrogen. Okay, like this. This is magnesium hydroxide. Okay, now. This is the importance of putting equal to 0 for neutral compound. Why? Okay, take note mga palangga. Okay, OH has a charge of -1. Take note, as a functional group in organic chemistry or even in organic chemistry. The same, right? OH, functional group. So, actually, we need to put parentheses here. Parentheses and put the -1 at the top of the OH. This is the precise way of doing it. Okay. Okay. Since again this is a compound, so it's got the total charge of the compound is 0. So equal to 0. Okay. Now, take note mga palangga. The H here is a positive charge. You got the point? So how can you attack for this? For this kind of problem. How can you attack for this kind of problem? Okay? You got the point? So, the best thing is to carry over the magnesium positive charge, which is positive 2. You have to put there outside the parentheses. Ganon. So, outside the parentheses. So, in that case, you will be able to remove the -1 already at the top of your H. Okay? You get the point? Actually, this is OH negative because the charge of OH is negative. It will be just removed because there's another compound exchanging their charges to become neutral compound, right? Because neutral compound, the charge is always 0. Okay? Get the point? Ganon. So, if always 0, so we terminate the negative charge of OH. We do it individually na. Okay? So, don't be confused in this part. Okay, now, we have, so this is gonna be 0 also, so equals to 0. Okay, now we need to determine the oxidation number of oxidation state of magnesium. So let X as an oxidation state, oxidation number of magnesium. So X. So So X times 1. Subscript of magnesium is 1, right? Then plus, individually, oxygen. The charge of oxygen is negative 2, right? So negative 2 times the subscript of oxygen. There's no subscript inside the parentheses, but there's a subscript outside the parentheses. It's just the same. Oxygen also is the owner for that. So negative 2 times 2. Okay? Now, plus hydrogen ata. So hydrogen, okay, positive 1. Don't carry the negative 1 because it's individual. If this is individual, the positive 1, not the negative 1 as OH ha. Again, it's very clear. So hydrogen, positive 1. Okay, positive 1. So 1. Then subscript of hydrogen inside the parenthesis is nothing. So nothing. But outside there's 2. So you have to multiply this by 2. Okay, like that. So solve mathematically. 1 times x is equals to x. Okay, negative 2 times 2 is equals to negative 4. Okay, 1 times 2 is equals to 0. Okay, negative 4, positive 2 is equals to x. Negative 2 is equals to 0. Then x transpose negative 2, it will become positive 2. So your oxidation number of magnesium is positive 2. Which is the same also the charge of the group 2A for magnesium. Okay? Then magnesium is 24.30 atomic weight. Okay. Ganon. Ganon siya. Now, put the individual charges here that we have. Positive 1 for hydrogen and negative 2 for oxygen. Now, going to the reactant. Okay, again, 0 water, 0 magnesium oxide. Okay, so negative 2 oxygen, then we directly put positive 2 to make it 0. The reverse. So positive 2 minus 2 is equal to 0. We do this thing directly because there's no subscript, chuba, chucho. Unlike here, there's a subscript, and there's a parenthesis. It needs mathematical operation to get exactly the oxidation. But in here, it's very easy. You have to equalize only and equal to 0. Then, bingo, kalas. Okay? Here also for water. For water is equal to 0. Now put negative 2 here. Oh, 2 times x is a positive 1, right? So it will equal to 0. So that's 0. Okay? The only issue here, if there's a parenthesis and subscript in your compound, that's only the issue in here. You need to scrutinize individually. Okay? You get the point? Okay, positive 1 mga palangga. Okay, now, determine if it's oxidation, reduction, blah, 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 chuba, chuchu. Okay, now, here, magnesium, positive 2 to positive 2. Diba? So, no changes. Okay? No changes to magnesium, Aqueous. So it will never do the reduction, it will never do also the oxidation. Okay, now for hydrogen, the spot, positive 1 and positive 1, X, Aqueous, meaning they will not also follow the reduction. Okay, what about the oxygen mga palangga? Still, negative 2, Aqueous, or this is not a redox equation. Okay, we try to solve first, but the theory says if all compounds in your reactants and products, it is not a redox. Okay, I'll just prove first why. That's why, by having the theory in our mind, then I prove that through individually discussing the mechanics and the pattern. That's why I told you, theory is more important in the pattern and mechanics. Or the methodology. It's always the theory or the concept or the principle. Okay? Like that. You get the point? Because you cannot force this to have a reduction oxidation because the rule said no changes in the oxidation state, therefore not redox. Kalas. No more chuba-chucho, no more pasikot-sikot or whatever. Okay. Number 4, magnesium oxide plus water is not a redox. Okay? Because sometimes also in a examination in the future, sometimes there will be a lot of chemical reaction and you need to identify if it is a redox, if it is a dissociation reaction, if it is a covalent bonding. Ikuan siya guys, irambol tanan. If this is a, grabe lagi, if this is a, chemical reaction, balanced chemical reaction, dissociation chemical reaction, dissociation reaction, redox reaction, ibutang yun dito tanan. Really, magbutang ka kung saan mong gusto. Ganon. Okay? So, muna siya purpose. That's the purpose. We can identify that it's not a redox. Okay? You get the point. So if it is not a redox, that's a plain chemical reaction. Meaning, hydrolysis chemical reaction. Because as I told you also, hydrolysis reaction and neutralization reaction are examples of double replacement and double displacement. And in the theory and in the principle, in the concept of this topic, that will not be a redox. Okay, we have in the theory itself, then bingo. Okay, now number 5. So let's do first the theory before doing the pattern and the mechanics and the methodology. Okay, so mercurous or mercuric, sorry, it's gonna be, it's gonna be mercuric oxide. Okay, mercuric. Okay, mercuric oxide, not mercury, mercuric oxide. Okay, we have also mercurous oxide because the mercury have two charges, the positive 1 and the positive 2, correct me if I'm wrong. Okay? There's no positive 3 in mercury based on my memorization. Okay? So it's equals to the mercury plus the oxygen gas. So for sure this is mercuric or mercury positive, mercury Roman numeral 2 oxide. Okay? That's the another name. Okay? Why? Because this is a molecular compound. Okay? Molecular compound, not an ionic compound. Okay? You get the point? Ganon. So let's do that. Redox. We are not doing the chemical reaction or dissociation reaction. We are doing the redox, reduction and oxidation reaction. Okay? Like that. So HGO. Okay, let's prove this. That's gonna be 2, Yes, because the oxygen is negative 2, then transpose the charges, then it will be neutralized, is equal to 0, then bingo. Okay, this is mercuric oxide, or mercury 2 oxide. Okay, then it will become mercury, okay, plus oxygen gas. Actually, other books stating oxygen, O2 is gas, mercury is a solid. Okay, and then mercuric oxide can be a aqueous solution or AQ in the different, if you can see different theories, books, Wikipedia or chemistry books or physics books or whatever. So it's gonna be like that sometimes, but we don't have to put that way. It's understood, something like that. It's take time also to put. Okay, you got the point? Okay, normally if you put aqueous, meaning there's a solvent involved. Solvent, it could be water or any other inorganic or organic solvent. That's why aqueous, something like that. Okay, but if all are solid, it's not an aqueous, of course. Okay, you got the point? Ganon. Okay, now start na tayo mga palangga. Now, we go to the reactant. So this is, okay, mercuric oxide. So, neutral compound, the charge is equal to 0. Okay, equal to 0. Oxygen negative 2. Negative 2, then X. Then X is equal to positive 2. Then positive 2 is the charge of mercury. So we are correct. The positive 2 plus negative 2 is equal to 0, right? Okay. Now we go to mercury solo flight, 0. Oxygen solo flight, oxygen gas, 0 also. Now determine oxidation and reduction. So oxidation meaning to loss of electrons, meaning gain. Loss of electrons meaning increase in oxidation number. So increase in the oxidation number will be the oxygen, right? See? From negative 2 to 0. There's an increase in oxidation number, meaning to say this is really loss of electrons. Loss of 2 electrons, then oxidation, and then this is oxidized. Okay, like that, and this is a reducing agent. Okay, so in this case, guys, in mercuric oxide, it deviates the normal interpretation that most of the nonmetals are oxidizing agents, right? Okay, because loss of electrons is oxidation and oxidized, therefore this is a reducing agent. Okay, not an oxidizing agent in this case. Okay, like that. Okay, and then the mercury, mga palangga, positive 2 to 0, decrease in oxidation number, meaning gain of electrons. Okay, gain of 2 electrons, then therefore reduction. Okay, then reduce, then oxidizing agent. So our oxidizing agent is the mercuric oxide. Okay, mercuric oxide. And our reducing agent is simply the oxygen. Okay, like that. You get the point? Muna siya natago, guys. Okay, so muna siya. So do the half reaction. Is this balanced? So not yet. You balance the chemical reaction. So 2 oxygen here. So actually you don't have to balance also, but it's very good to balance because sometimes also, I will tell you okay, there's a problem like this, as far as I can remember, the board examination, it's a type of equation that's redox. And at the same time, though it is a redox, the question says, A, which is the reducing agent? But then, asking also, what is the grams of, for example, in this case, what is the grams of mercuric oxide that will react to blah, 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 to produce like this at a temperature, blah, 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 with a velocity, like this. All are being connected in one problem. The velocity, the area of the pipeline. Then sometimes you'll be, why like this? It's in the topic of redox, and then talking about the motion of the gas in a pipeline. See? So you have to say also that even though this is a redox, we need also to balance. Okay? Because there are questions like this, mixing all the furies in one problem. Okay? May bungon ka, ngayon yung diameter of the diameter of the pipe, the inlet pipe, and the outlet, for the flow of like this, and then starting with the redox, like this. The purpose of the redox only is to determine which is oxidized, which is like this, like that, and then add the other quantities. Okay, so this is the example of maximization of your academic potential. Okay, or your understanding with the coverage of your science. Okay, now we go back here to the half reactions first. Oxidation half reaction. So OHR, diba? So oxidation, ang palangga is oxygen, right? So oxidation meaning loss of electrons. So the adding of electrons is in the right? So it's gonna be, so oxygen, negative 2. So plus oxygen gas plus 2 electrons to the right ng good shot. Okay, ganon. Okay, and then here, negative 2. Oh, diba? So this is the oxidation. Oxygen, negative 2 is equal to oxygen gas O2 plus 2 electrons. This is your oxidation half reaction. Okay, the other one is mercuric oxide. Okay, then you take only the mercury, of course. Okay, like that. Because that is half. That's why half, because you carry only the one element in a compound. Okay, meaning not the complete reaction, of course. So Hg. So that is reduction, gaining of electrons. So the adding of electrons is in the right. No, it's in the left, sorry. So plus 2 electrons, and then this is mercury positive 2, like that, is equal to, like that. Okay, mercury with charge 0. But no need to put the 0. It's just the same with nothing. Okay, like the 2 electrons. Then add the 2, cancels the 2 electrons immediately. Then you will say oxygen negative 2 plus Hg positive 2 is equals to Ag plus 2 electrons. Hg plus 2 electrons. Ganon. Okay, like that. Ito po yung mga palangga. Yap. Okay, then since this is 2, because there's a 2 electrons here, so 2 electrons balance, kalas. Okay, ganon. That is number 5. Diba? Okay, the question so far. Number 5 is redox. Okay. Number 6, magnesium solid plus hydrochloric acid aqueous. Okay. Aqueous, so meaning to say this is a solution, right? Nakakaloka. O, diba? So HCl plus water, how can we do that? It's aqueous, right? So let's have the formula. Okay, HCl plus water, right? Oh, nakakaloka. So it's gonna be, wait, hypochlorite ba siya, guys? No, on the spot, mga palangga. So it's difficult to say HCl because there's already HCl already. So this is hydrolysis.